We now discuss the solution of a problem from the section Integral Calculus, and this given problem is on the evaluation of a definite integral involving a trigonometric and a greatest integer function. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is integral 0 to 5 cos of in brackets pi multiplied by x minus bracket x by 2 with respect to x, where bracket t denotes greatest integer less than or equal to t is equal to, that is the integral is equal to. We are given four options. Option A minus 3, option B minus 2, option C 2, option D 0. Required to evaluate this integral, the integral 0 to 5 cos of pi multiplied by x minus bracket x by 2, that is the greatest integer function of x by 2 with respect to x. We now discuss the solution of the problem in detail. We take the integral and call it as the I. Then the I is equal to integral 0 to 5 cos of pi multiplied by in brackets x minus bracket x by 2 dx, where bracket x by 2 is the greatest integer function of x by 2. For this, we propose a substitution. Put x by 2, this x by 2 is u, then x will be 2 times u, differentiating dx is equal to 2 times du. Since this is a definite integral, the integrals will change according to the new variable. So when x is equal to 0, u will be 0. And when x is equal to 5, u will be 2u will be 5, u will be 5 by 2. Now that is equal to the integral 0 to 5 by 2 cos of pi in brackets x is 2u minus bracket x by 2, that is bracket u, dx is 2 times du, 2 times du. Now 2 is a constant, it will come out, and that will be equal to 2 times this integral 0 to 5 by 2 cos of pi of 2u minus bracket u with respect to u. Now this integral from 0 to 5 by 2 is written as integral 0 to 1 plus integral 1 to 2 plus integral 2 to 5 by 2. Why? Because the integral 0 to 1 bracket u is different from the integral 1 to 2 bracket u is different, 2 to 5 by 2 bracket u is different. So in the interval 0 to 1 bracket u is 0, the greatest integer not exceeding that u, that is, so that will be 1. And bracket u in the interval 1 to 2 is 1. Bracket u in the interval 0 to 1 is 0 in the first integral. In the second integral, bracket u in the interval 1 to 2 is 1. And bracket u in the interval 2 to 5 by 2 is 2. Substitute them. So this will be 2 times integral 0 to 1 cos of, this is 0, cos of 2 pi u du. Integral 1 to 2 cos of pi of 2u minus 1 du, because bracket u is 1. And integral 2 to 5 by 2 cos of in brackets 2u minus 2 with respect to u. And bracket u is 2 in this interval. Agreed. Now integrate. 2 times in brackets cos of 2 pi u. Integral of cos is sine. Sine 2 pi u by sine 2 pi. To be evaluated between 0 to 1. Plus this integral is sine of pi into 2u minus 1 by 2 pi. To be evaluated between 1 to 2. Plus this integral is sine of pi in brackets 2u minus 2 by 2 pi to be evaluated between the limits 2 to 5 by 2. So that's what we have written here. Agreed. This 2 pi we will take out. 2 pi is common. So 2 by 2 pi is equal to sine 2 pi u to be evaluated between 1 and 0. So for the upper limit it will be sine 2 pi minus sine 0. In this, similarly in this 2u minus 1, when you substitute for 2, this will be 2 2s are 4 minus 1, 3 pi. 3 pi minus sine 3 pi minus sine pi. Plus here for the upper limit 2 into 5 by 2, 5. 5 minus 2, 3. So sine 3 pi minus sine 2 pi. So this will be 2 by 2 pi, sine 2 pi minus sine 0 plus sine 3 pi minus sine pi plus sine 3 pi minus sine 2 pi. And notice that sine 0 is 0, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0. So everything is 0. So it will be, the answer is 0. Let's look at our options. Our answer 0 appears against option D. Therefore, the answer to this question is option D. So that is the complete discussion in detail of the solution of the given problem. And it is a very simple and straightforward question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.